Oscillating pendulum. The transformation of energy from one form to another is explained using energy conservation principle. In an oscillating pendulum, during the to and fro motion, kinetic energy is getting converted to potential energy and vice versa. But the total mechanical energy remains the same. Hence no energy is created or destroyed but transferred from one form to another. A skier sliding down the hill. For a skier sliding down the hill, energy transformations occur between gravitational potential energy of the skier to his/her kinetic energy. In addition, thermal energy may be generated as part of friction. For the whole system, total energy remains conserved. A car moving up the hill. Here also, the gravitational potential energy and kinetic energy plays the role. Energy remains conserved in the system. Inside a nuclear power plant. The conservation of energy uses are visibly present in the power plants where energy is generated from reactions for other purposes. In a nuclear power plant, from the decay of the radioactive element, electrical energy is generated. A series of energy transformation steps occur in between the process. Hence the electrical energy is not produced out of nowhere, but from nuclear energy. Energy is therefore conserved in the process. Inside a hydroelectric power plant. Similar to a nuclear power plant, a hydroelectric power plant generates electricity from the mechanical energy of water. This is another instance where energy is conserved. Batteries. Batteries are extensively used as source of power for almost all devices. Chemical energy stored in batteries are transformed to electrical energy. There is neither creation nor destruction of any energy during the process. A ball tossed up in the air. A ball tossed up in the air initially possesses kinetic energy and then gravitational potential energy. The total energy of the system remains the same. Fireworks. Firecrackers and fireworks used at festivals are a source of heat and light energy. These energies are not generated out of nowhere, but instead are transformed from the chemical energy stored in the chemicals that make up fireworks. Conservation of energy uses frequently asked questions. When to use conservation of energy? Conservation of mechanical energy is the most widely used principle in mechanics to predict results after collisions, free fall, etc. The conservation of energy mechanical principle seems to be very helpful in solving situations where the conservative forces are involved. Gravitational force, spring force, etc. are conservative forces. This implies that the law applies to isolated systems. In such situations, other non-conservative forces or the environmental factors are considered negligible. The statement of conservation of energy goes this way. Energy can neither be created nor destroyed, but it can be transferred from one form to another. Thus, in an isolated system, the total energy remains conserved. When to not to use conservation of energy? Even though conservation of energy is a universally used principle, there are certain instances where its usage is restricted or is used in a modified form. As discussed before, energy conservation principle holds good for isolated systems. Whereas when interaction happens between two systems, the conservation of energy cannot be applied for one system. There is a need to consider the effects of both systems to evaluate the situation. There is also a case where Einstein introduced mass-energy equivalence wherein total mass and energy of a system remains the same. This is applicable in situations where nuclear reactions occur. Why use conservation of energy? The conservation of energy is applied in several areas of physics to ease the calculations. The principle of conservation of energy is used to solve several physics numerical assuming the energy for an isolated system is conserved. This energy conservation law helps us to predict the results in instances like collisions, free fall, other problems in mechanics, etc. In mechanics, problem solving is made easier using kinematic equations. But conservation of energy saves the time even further and helps in solving in a much better way. Where to use conservation of energy? Energy is a vital element in physics that governs most of the phenomena. Hence, conservation principle is a boon for solving almost all problems. To solve numerical problems involving isolated systems and conservative forces, energy conservation principle is much efficient. However, there are certain situations where instead of energy conservation, a new principle developed by Einstein called mass-energy equivalence is used. Such cases are found in nuclear reactions in the sun, in particle accelerators, etc. It is because some mass gets converted to energy. In conserved systems, we neglect the effect of energy lost through friction or any other non-conservative forces. This makes the calculations easier. The conservation of energy principle is used in systems where something undergoes collisions. If it is elastic collision, conservation of mechanical energy is used. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.